The main advantages of this method are that it is fast, easy, environmentally friendly, and allows for tailoring of materials.
This method can provide insight into how bioinspired silica is formed, the available ways of incorporation of biomolecules, and the post-synthetic material treatment. Generally, individuals new to this method will struggle because silica formation is rapid and a specific amount of acid needs to be added quickly in order to obtain the optimum results.
We first had the idea of this method when we realized how mild it was, such that the conditions were compatible with enzymes. We thought of using this method to enhance enzyme performance and stability.
Visual demonstration of this method is critical as the acid neutralization step is the most important for the final material properties.
First, weigh 318.2 milligrams of sodium silicate pentahydrate into a 180 milliliter plastic container and dissolve in 20 milliliters of deionized water. In a second container, weigh 58.1 milligrams of pentaethylene hexamine, or PEHA, and dissolve in 20 milliliters of deionized water. Subtract this amount of water from the volume of deionized water to be used for the dissolution of sodium silicate pentahydrate. To perform in situ encapsulation during synthesis, dissolve a predetermined mass of protein in 5 milliliters of deionized water and place the solution in the refrigerator for total dissolution. Check occasionally on the dissolution progress, preferably without stirring. Combine the sodium silicate pentahydrate and PEHA solutions in one of the containers and add sufficient deionized water.